Hello student. Yes, so in this video we are tackling the concept of factorization. It is a very amazing and simple concept to master. Yeah. So what is factorization and what does it entail? Factorization is simply seeing something and pulling out what is common between 2, 3, 4 or 8 things, or many things. We are removing what is common in those things, as simple as that. For example, if I have if I'm given a x squared plus a b, maybe plus ab, and they tell me to factorize what is common between ax squared and ab is an a, so I pull it out, I factorize it out. So I'm going to be having an a into x squared plus b. I factorized that expression. Or I can have if I have maybe a squared c plus sc, and I'm required to factorize that. So what is common between a squared c and ac? I see an a here, I see an a here, a c and a c. So a is common, so I can pull out a. Still c is common, I can pull out a c. So that what do I remain here? When I remove a c from this guy, I remain with only a c, plus when I remove a c from here, I remain with a 1. So I put there 1. I factorize the above expression. So one of the very amazing concepts under factorization is what we call a difference of two squares. So assume I'm told to factorize, if I'm told to factorize x squared minus y squared. So how do I factorize that? A difference of two squares simplifies life in mathematics. If I'm to factorize this, I take a difference of two squares. It says you add the two components multiplied by the subtraction of the two components. In other words, I'm going to have x plus y into open brackets x minus y as my difference of two squares. But then the difference of two squares can be actually extended to higher level phenomena. For example, if I have a number like 3, I can have a number like 3. Assume I have a number like 3. So maybe this was 1, this is 2. So if I have a number like 3 x power 4 minus maybe 48 y power 4, I look at that, it looks strange, it looks amazing, it looks tantalizing. So what is common between these two guys is a 3. So I factorize out, I pull out a 3. What remains behind here? It is an x power 4 minus what remains behind on this guy is a 16 y power 4. So I look at those guys, still there is more that I can do to them. So what I can do is I have a 3 here, so I want to introduce a difference of two squares here. So I can have here an x squared again squared minus such that this guy is the same as 2 power 4. This is 2 power 4, which is the same as 2 squared again squared. Then y power 4 is the same as y squared again squared. So what I do here, I can regress these squares into one square and these ones into one square, so that I can have this at 3 into open brackets x squared again squared minus a 2y, the first square, and then I'm adding on the second square. So what I do is I take this guy as one number, I also take the whole of this guy as one number, such that I take a difference of two squares. So if I take a difference of two squares here, I can have a 3 into open brackets, I'm going to have the x squared plus 2y, this guy is squared, this is my first part. Then I can still have we are multiplying these two brackets, I can have x squared, then minus 2y squared. Hope student, we are together. So that is the difference of two squares between this guy and this guy. I add these two, this and this, I add them, then I get this minus this guy. But when I look at these two guys, there is a continuation of the difference of two squares, because I take this one as one number that has a square and this guy as another one that has a square. So I can further factorize. I can have a 3 into open brackets. These ones, there is a positive, so there is a plus, so there is no difference of two squares here, because a difference is simply when we are subtracting, such that I have that, then into brackets a difference of two squares, x plus 2y, then again into x minus 2y, then I can close here, then I close there, and then I can further simplify this guy so that I have a 3 into open brackets, I have an x plus 4y squared, this is x squared, then into x plus 2y, close that, into x minus 2y, close that, and then I close here, and that is my factorization. It is as beautiful as that. So we have here another interesting question. They say factorize completely, but all still that we need to see here is the fact that this is a difference of two squares. This is like one number a, this one is like b. It's like b squared minus a squared, which is a difference of two squares. So what we do is we take a difference of two squares, I add these two guys, so I have an x plus 4 plus x minus 3, and this is going to be brackets x plus 4 minus open brackets x minus 3. I introduce a bracket because there are two numbers in here, that's why I'm introducing a bracket, so that x plus this guy, I get this guy as this and that, I get this guy as 2x, I get this guy as 2x, 4 minus 3 plus 1 into open brackets. This guy is going to be x plus 4 minus x, then minus minus gets me a plus 3, such that x and x go, this and that guy, they go to 7. So I have a 7 into open brackets, a 7 into open brackets, 2x plus 1. So I can leave my answer as that because they've told me to factorize. I may not multiply a 7 throughout because the 7 will be there as something that is common. Plus twice a b.